In this section and the following sections, we'll cover some of the basic commands that are helpful for you to know within a Bash shell scripting environment. Now, Bash, unlike other programming environments such as PHP, Perl, Python, etc., does not have a wealth of built-in functions, and as a result, you need to rely upon the existence of certain standard Unix commands to be available on your system, or standard Linux commands. And essentially you use Bash shell scripts to string together the standard utilities that you'll expect to find on your Linux box to perform certain functions. So part of the flexibility in shell scripting is that you rely upon and expect certain utilities to be on the system in order for your scripts to work, and perhaps at the top of your script or in the comment section you can mention which utilities are required, and perhaps even if there are any version-specific utilities that are required. But it's also problematic at times in that not all systems will have all the same versions of the same utilities, and some systems may be missing some of the utilities that you expect in order for your script to be successful, which is why other scripting languages are sometimes more ideal for getting things done. But generally speaking, most Linux systems ship with the utilities that we'll be mentioning, and you have to know how to use them because within your scripts you'll inevitably make calls to them. Let's begin with one of our first commands, and it is the cat command. The cat command is short for concatenation. You can do cat help or man cat, and you'll see some of the options that are available. It concatenates any of the files that you pass into it using standard input. So for example, you can pass multiple files into cat and send the output into one file, and that's where it performs concatenation. Or you can display some of the contents of a file such as tabs and other characters, show the ends of the files, etc. There's a complementary command, and that's complementary with an E, and for cat called tac, T-A-C, which performs the reverse of cat. So tac, which we'll look at after cat, will just do everything cat does, but it reads or displays from the end of the file versus from the beginning of the file. So by default, when cat operates on a file, it begins with the beginning of the file, which is logical, the header of the file, the top of the file, and works its way on towards the bottom of the file. Tac does the reverse. Now let's show you how cat would work in its basic sense. We'll create a new file, and here's another command you expected to know. It's called touch. We'll go into it shortly. Touch allows you to create a new file or to update the access modified times on files. Let's touch a new file. We'll call it data1, and we'll nano data1, and we'll put some values in there. We'll put Linux CBT, no spaces, then a new line character. We'll put scripting space edition. Let's put Red Hat tab edition, and let's see what we have available when we evaluate these three lines. So when we cat a file, by default it accepts on standard in the redirection to the file name. So by specifying data1, it reads it directly using redirection. You could alternatively say cat less than data1, and it would perform the same function. Now it doesn't seem to do much. If you're accustomed to DOS, cat is similar to the type command in that it'll dump to your screen the contents of the file. If you notice, there were some other switches, some other options that cat provides if you do a cat-help. If you do -A, and that's a capital A, remember within Linux all options are case sensitive. If you do a cat-A on the same file, data1 for example, look at the difference. It prints a $sign indicating the end of a line, which by the way, a $sign is used in regular expressions which we go into in Perl, Python, and it uses regular expressions, or it echoes the same symbol that a regular expression uses, the $sign, to indicate the end of a line. Additionally, it echoes a caret symbol plus the I character to indicate a tab, and it tells you in the help. You don't need to memorize it. It tells you if you just want to show tabs, or if you do all, it shows everything. And a tab is represented whenever found in a file using a caret symbol and an I. So in other words, cat evaluates, it sees everything within the file, and it's able to echo it to you. Its default state is to not show you the symbols contained within the file. So again, cat data1 just shows it to you the way we created it. Cat all shows you all of the embedded strings. And then there are other options that allow us to go in between the full extreme and the default. So in between all and just a few. So for example, we can show tabs. We can squeeze blanks. So let's say we had multiple blanks within a file. Let's show you how that would work. Well, nano data1 again. Nano is yet another command you should know. It's not available on all Linux systems. It certainly just became available as a default option within a Red Hat environment for Fedora, but for Red Hat 9 it's something you need to install. It's just an alternative editor to Pico. So we'll nano data1, and let's create some space. I didn't count the number of spaces, but we have a number of spaces there, and then we'll add something else in here. For example, we'll put Debian tab edition. We'll exit the file. Now let's cat-all data1. It shows everything. It shows new lines as indicated here. Now how about if we were to suppress the squeeze, which is essentially a suppression using the S option, the blank lines. We can cat-s and data1. Now by the way, whenever you're looking at help options within a Linux environment, you'll tend to find that commands, especially GNU compliant commands, support two forms of options, short and long forms. And there's actually a utility getops which will allow us to process these options. Well, again, commands typically have two ways of specifying the same thing. So we can do uppercase E or show ends, for example. So now back to our example. If we do cat-s, notice that there's now only a one-line difference between Red Hat Edition and Debian, or Red Hat Tab Edition and Debian Tab Edition. But if we cat it without the S option, it preserves everything, and then there are multiple lines which we can count, which appears to be approximately 4 lines in between the two. So again, cat has its purposes. Now what were we talking about concatenation? What do we mean? So we have this file, data1. Let's make another file. We'll nano data1a, and we'll specify within data1a some additional text, and we'll say additional text file data1a, just additional stuff. Now let's exit this. Now we have two files, data1 and data1a. Let's show you how concatenation works in its general form. If we cat data1 as well as data1a to perhaps data1b, then the output from the first two files will be redirected, providing we separate them using the redirection option, to data1b. Let's take a look at that. Now, if we lsltr, you'll see we have this file data1b. We can cat data1b, and it will contain the data in data1a, the original, as well as the additional text and file data1a, which comes from the two files. So cat, again, performs concatenation. Now, what about tac? If we tac data1, let's see what happens. It prints everything in reverse. Debian tab edition is the last line when we cat the same file. Let's take a look at that. We'll cat data1, and you'll see Debian edition is the last line. Tac just performs the reverse. So if you need to look at a text file, for example, in the exact reverse, with everything else preserved, all of the blank lines, all the tabs and special characters, just use tac. The which command tells you where the command's located within the file system, if it's somewhere within your path. So if you do which cat, it tells you that cat is located within /bin. Now there's a whole lesson on the file system hierarchical standard that we go through in the Red Hat edition, which tells you why certain directories are the way they are within a Linux environment. Which tac tells you that tac is within user bin tac, because tac is not an essential command as cat is. So cat is a very important command. It allows us to dump to the screen the contents of our text files. We can also concatenate multiple files and send those files to a destination file if we'd like. Now we mentioned previously touch. Touch again creates a new file. It creates a new 0-byte file. So if we touch, let's say, data 1C and LSL data 1C, you'll see we've just created this new file and it matches our timestamp. It's a 0-byte file. Now touch in its default form will create the file name that you've specified on standard input if it doesn't exist. Now if the file does exist, it updates the timestamp. You'll see what we mean. If we LSL data 1, for example, we created this particular file at 2003. It's now 2007, almost 2008. If we touch data 1 right now, although it exists, we will not overwrite its contents. We'll simply update the two file stamps that are maintained by Linux files. The access time as well as the modification time. Not the creation time, but the access time and the modification time. So let's touch data 1 and it's now 2008. The time will be updated. Now let's LSL again data 1 and you'll see that the date timestamp has been updated to reflect 2008, whereas it was just 2003. What does this all mean? Well, from your script, you may want to make these sorts of changes as you're writing your script or as you're going through your script. You may want to update the access time and modification time of a file by simply just putting a one-liner which says touch and the file name. That would make the change for you. Or within your script, you may want to cat, for example, var log, let's say messages, which is the system messages file. You may want to cat it, dump the contents to the screen, and somehow manipulate the contents. Perhaps you'd like to grep for something, such as fail, if it exists in the log, or something else. So again, that's what you would do from the script using the embedded Linux commands. The way shell scripting works is that you glue together multiple commands that you're expected to know, and if you don't know, you do some research on your system to figure out how to use those commands. So you're essentially gluing together the commands that are available on any standard or stock Linux system. It isn't significantly different from programming, let's say, within a standard environment such as Perl, PHP, or Python, with the exception of those languages are more tightly woven, whereas shell scripting is more loosely woven, and there are more likely to be, it's more likely to surface discrepancies, bugs, problems, etc. So if you need tight programming and more reliability, don't use shell scripting, because things are likely to change, such as some of these little commands that we're showing you, such as touch, cat, tac, etc. Here's another command, WC, a very popular command. Now we've created this data 1 file, and it contains a bunch of lines. If you use the WC command, by default, this particular command, run it with help, you'll see if you use WC, it'll count by default. Let's show you WC data 1. It'll count what you see here. These are the number of lines in the file. These are the number of the words that are in the file, as well as the number of characters in the file. So lines, words, as well as characters in the file. However, you can specify the individual options. So let's say you wanted just a line count, WC-L, data 1, and it'll give you the line count. It contains 8 lines. If you cat data 1 and count them, you'll see here are the first 3 lines. You can count the spaces. These should equate to 4 lines for 7, and the final line is 8. You can count the words and other options. So WC is very important. Now again, how would you use this in a scripting environment? You may want to make a decision based on the number of lines in a given file. So you can set a variable such as this, for example. You may say in a script, line count is equal to WC, and you'd use command substitution, WC-L, data 1. Now we have a variable called line count that the bash shell keeps track of. So we can actually echo line count, and there's now a value stored within it, and it's the value 8. Now we may not want, of course, data 1 stored in it, which is what happens when we do WCL data 1. You may not want the actual word data 1, so you can just cut the number out to get the particular integer, and that's yet another command. So for example, we could cut, and the field separator is a space, and we want, or the delimiter is a space, and we want the first field. And in this case, it's actually tabbed over, and it's doing it based on exact spaces. So this may actually be a full tab. And let's go back one, and we've gotten the value 8. So in fact, it's at the 7th position. So this is a way you'd actually get the number of lines by cutting the F field, using the field that you want, the D for the delimiter, and pulling just this particular number. We went through it because there were X number of character spaces prior to it. So cut is yet another command, which is like a really slimmed down version of a pretty complex program called awk. And there are other commands. Of course, you can list the directory. Now you may be wondering, why again would listing the directory be important in a shell script? Well, if you think about it, what if you wanted, for example, a count of the number of files in a directory? Well, if you LSL, or if you LSL ALI, for example, this shows everything in the directory, including all of the inherent default dot and dot dot, the implied directories for the current and the parent directory respectively. Well, if you do an LSA, this shows you just the files in the directory. And then if you pass this into a program such as word count using piping, which of course we have a section on piping, you pass this into word count, it returns a number of files in this directory. So that's what you would do. So that's yet another command, ls, and ls certainly has many options, too many to mention in just this particular video. There's so many in here, which in addition, as I mentioned before, back to the access time and the modification times of the file, it'll tell you if you wanted the times, you could do it. For example, we have the data1 file. We could do something such as the following: ls time _ equals, let's say, the access time, the last access time. We'll dump it LTR, and we're interested in the data1 file. And this tells us the last access time was at 2012. But what about the modification time? Well, we can change this to C time, and it'll give us the modification time was 2008. Now, what if we made changes to data1 right now? Would it be updated? Certainly would be. Let's just specify in here bash edition, exit this, and try that again. Now, the access time remains the same, but the modification time has been updated to 2015, which it currently is, 2015. But let's take a look at the access time. It has not changed. It's still, or actually it's just changed because it's now 2015, because we just actually accessed the file. But in general, it wouldn't have changed. One would have changed, but not the other. There's yet another command you want to know about. It's called sleep. Sleep will accept the number of seconds that the script should sleep for. Let's say, for example, you want a script to run in a jagged fashion, to perhaps pause at certain intervals and resume in less than an interval that's allowed by the cron schedule. The cron schedule allows you to schedule tasks with a minimum frequency of every minute. But let's say you want to sleep for, let's say, every 5 seconds. Well, somewhere in your script, simply place sleep, and let's say 5. Your script will do exactly what you see now. It sleeps for 5 seconds, and then it resumes operation. Let's look at that again. You sleep for 2 seconds, 1, 2, and then it resumes. If you need smaller time intervals, use usleep. Usleep is measured in microseconds, so this will seem instantaneous. So in order to get a full 2 seconds, you'd have to go up to 2 million, and that'll give you 2 seconds. Again, if you need smaller intervals, then just cut it down because it's measured in a microsecond. So we've talked briefly about cat, tac. Tac does the exact reverse of cat. Touch for creating new files or for updating the access and modification timestamps on files. And we also mentioned WC. WC is a very popular command in shell scripting. You can't do without it because you can count bytes, you can count lines. Usually you use it for line counting. You can even count words. It'll read the words. For example, WC-W on data 1, and it'll count the actual words. And you can actually cat data 1 to see if you agree. For example, this is the first, second, and third, fourth, fifth, sixth, seventh, eighth, ninth word. So it even counts the words for you. WC is important. ls is too much to talk about, but there's some basics, like we gave you a little example, such as listing the directory and doing a file count. And then there's the sleep command. There are tons and tons of other commands that you're expected to know. We'll talk about some more of them, because the thing is, we weave these commands into our shell scripts to get certain things done. Now let's move on to some other commands. We have the time command, for example. The time command actually keeps track of how long a process has run. So, for example, if you're interested in metrics for the length that it took your script to run, use the time command. You can do a which time, and you'll see that time is located in user bin. Now, in order to test time, you can test it against any command that's already available in the system. You don't need to write a script. So simply run time and the name of the command. And optionally, you can specify time help to see the switches that are available. But almost anything you run against time will cause it to generate the real user and system times. Generally, you're interested in the real time, which covers or indicates the time from invocation to completion. Man time will return additional information about the time command, and you can use time against any command on the system, including existing scripts. So, for example, let's time the sleep command. The sleep command, as we've mentioned, is a separate command that allows you to pause your script. So, for example, if you wanted to keep your script resident to have certain areas run at certain intervals, you could use the sleep command. Let's time sleep for 3 seconds. Now, ideally, this should take 3 seconds, but it actually takes a little longer. As you can see, it took a little over 3 seconds from invocation to completion, which it should. It takes time to actually create the process in the system's process table, and then to actually terminate or kill the process. Which brings to mind another command, the PS command. PS AUX is typically a way to run PS. PS accepts many switches, many options, many arguments, and across unices and linices there may be differences in the options that are accepted, as is the case with most commands in general across Linux and Unix. But if it's GNU compliant, you'll find that the particular command such as PS will accept similar switches, such as AUX, which will show all processes for all users, etc. PS lists all processes, and when used in conjunction with piping and perhaps grep, allows you to parse the process listing table for specific processes. So, for example, we have instances of Python, Bash, etc. Let's just grep for Bash, and it'll return all of the instances of Bash as they are running on the system. And there are quite a few, which indicates that there are other windows open for other sessions, for other users, logged in as root, of course, to the system. So PS will list all the processes running, and an ideal way to run it is with AUX. There are other ways that you can run it, but AUX will list all processes, and you can pipe the output into some other command to make sense of it. If otherwise, it will just run across the screen. Now, within a script, once again, since this is the scripting edition, we should make ties wherever possible to how it's applicable to a script. Almost any command within a Linux environment can handle standard input, standard output, standard error, the typical file descriptors within a Linux environment. So what that means is as follows. From within your script, you should be able to query the system using almost any standard Linux, Unix command to ascertain whatever information you're interested in. So, for example, let's say you've written a script to parse the process listing table, as we've done here, as we've listed using PS, but you're interested in specific processes. Maybe if you see too many instances of a certain process, it'll invoke a section of your script, perhaps a function which will actually kill the process ID. So we've grepped for Bash, and it's returned multiple instances. We could, for example, send all of this output to cut and perhaps get the second column, which returns the process ID, and then have kill, after storing the process ID into a variable, have kill actually kill that process ID. That's quite possible. So again, we make use of the output, we feed it into a variable after parsing using a tool such as cut or awk, or even grep, and then we act on it. So PS will list the processes that are running on the system. There's also the top command. Now typically you don't use top from within a shell script, but it is a nicely presented picture view of your current process listings, as well as memory, as well as swap, so both virtual and physical memory usage, CPU usage, and the most common processes. And you can tab through the processes that are running on the system, you can refresh it, etc. This is a nice snapshot of what's going on currently on your system. You typically don't run top from within a script. You're more likely to run PS because PS will dump the output so that you can manipulate it, whereas top refreshes quite often. Another command is actually useful is the watch command. Watch by default will refresh every 2 seconds, and you can change the interval, of course. Just do a watch help and you'll see how to change the interval using the N option, the short option N. If you do watch, let's watch, and we'll watch tail var log messages. This is a simple way to monitor your system logs. It may even be a way for you from your script to export the output of the bottom of the script. And if you're interested in why you'd be watching the bottom of the script, or the bottom of the file, because log files are written in a linear fashion. So in other words, they're appended towards the end. So you normally want to watch the end of a log file. And oftentimes you want the values from the end of a log file. For example, you may have log files that span 1 or more days or even weeks. So as a result, you'll find the newest information towards the bottom of the file. So we've mentioned a few commands already. PS, we have time. Again, we can run time with anything. So we can say, for example, time, tail, varlog messages, and this will tell us how much time. Typically, we're interested in the real time versus user and system. Real is under a second, so we're running pretty well. It should run pretty fast. Another important command, the date command. The date command is very important because so much of what we do in life and within computer science is contingent upon the current date or on some other date, but measured against the date. And typically anything that we do on a computer system has some sort of date and or timestamp associated with it. If you do a date-help, you'll see many options. And by default, if you're displaying on a small screen as we are, what you'll see is what you see here, or something similar, which are the formatting options that can be applied to the date. In its default state, if you type date with no options, you get a full printout, including the day of the week, the month, the short month. Both values are echoed short, and they're variables that correspond to the formatting that you see here, which allows us to change the formatting whenever we use the date command. We have the actual day of the month, time, etc., time zone, and the year. Now the date command operates in several ways. It allows us to export the date in many formats so that we can use it in the right context within our script. For example, here's a neat way to use the date within a script. Let's look at some of the scripts that are in this directory currently. Well, LSL, and there are a bunch of scripts. And for example, let's look at the while loop 1.shell. It was supposedly modified last on August 28th at 13:52. Well, we can do, for example, date R on the same file, while loop 1.shell. And as you can see, it even breaks it down to the second. Perhaps we're interested in storing these values or a subset of these values within our script for processing. Maybe we're doing some comparisons based on when the file was last modified. Well, the date command is the command to use because although this doesn't seem like much, it's returning the same standard output. We can then parse the output of date, the standard output of date, by applying formatting. And let's show you how to do that. If you do a date help, you'll see that some of the formatting options are presented with prefixes of %. In order to achieve or make use of formatting with the date command within a bash environment, you prefix the formatted variables or the formatting variables with a plus symbol. So you say, for example, date, specify your options. In this case, we read the last modification time, date timestamp from a file, and then we specify prior to the formatting the plus symbol, and then the format that we're interested in. So what if we wanted to change the last modification time of the while loop file to, let's say, Unix time, which is the number of seconds since January 1st, 1970? Quite easy. Just do date and specify the -R option to read the last modification date timestamp from while loop 1.shell. This echoes the basic information, but now we make or we append to the output plus %, for example, s. %s will format and present to you the number of seconds since the Unix epoch up until the last modification time of while loop 1.shell. Typically, when you're performing comparisons within programming languages, especially within Linux, we rely upon or we perform operations based on the number of seconds since the Unix epoch. Since it's broken down into seconds, we can easily compare and contrast. In other words, we can add, subtract, etc. So the while loop 1.shell script file was last modified X number of seconds after the Unix epoch, and the current number of seconds since the Unix epoch can be reflected by doing the following, just simply echoing date plus for formatting %s. This echoes the current number of seconds, and if you keep running it at least once per second, you'll see the seconds incrementing. So let's run through that again. We'll clear screen, and we'll do a date-r on the while loop 1.shell file with the special formatting of %s. It gave us this number, and this number ends with 573. And now we do a simple date, and we get a new number. We can compare these two using conditionals within our scripts. We may want to make decisions on files based on whether or not the last modification time has changed, for example. And if there is a difference, you'll know. So in other words, if the difference between, let's say, the last access time or the last modification time on the file and the current time exceeds your criteria, then you can make some sort of decisions. So in other words, you'd want to compare the two values, which leads us into another command, which is the express command. So again, research date, just the date help. You'll see all the other ways you can format to output your date. You can just pick any of these variables, for example. You can do, let's say, date plus %d, for example, and it just echoes 20. Or you can combine them, perhaps separating them with a character that isn't interpreted, and just echo anything else that you're interested in, and it'll print to the screen. And just keep typing the variables in any order you want, and Linux will return it appropriately for you. Another command that comes to mind is the expression command, expr for short. You can do a which expr. Express or expression allows us to evaluate expressions. Most scripting environments, like the ones that we will show you throughout the scripting edition, have expressions built in by default. We can perform tests, comparisons using other scripting environments because they're all built in. Within Bash, you typically need to make use of a third-party utility to do most of the grunt work or the hard work for you, such as evaluating expressions. Well, what do we mean by evaluating expressions? Well, you can evaluate arithmetic expressions, such as 2 arguments added, subtracted, etc. You can perform comparison. Is the left less than the right, or is the left equal to the right, or is the left not equal to the right? And you can perform comparisons with strings, whether or not strings are equal. You can ascertain the length of a string. That's often important. Sometimes you may be parsing through a file with your shell script or reading in data from a file using your shell script. And if you, for example, use the expression command, abbreviated once again as expr, express, you can ascertain the length of the string quite easily. Perhaps you'd like to extract a substring from the string that you have in question. There's certainly an option for that provided to us by the express command. So simply doing a man express will return many of the options that are available. Here are some of the comparison operators, the common ones: less than or equal to, etc., greater than. We have arithmetic operators, subtraction, multiplication, and we have string operations such as matching, substring, index, etc. Let's look at a few of them. Let's say you want to express, for example, 10 plus 10. Now you need to separate the 2 arguments by spaces, so the operator should have a space between both arguments on the left and the right, as you see here. In other words, don't juxtapose them without a space. Make a space. Express 10 plus 10 returns 20. Express 10 plus 100 returns 110. So we can do simple addition. How about multiplication? Well, 10 times 100 should return 1000, but this is going to yield an error. And that is because the asterisk is a reserved character. It's a special meta character within the bash environment, so it needs to be escaped. The asterisk, as you should know from DOS as well as Linux, Unix, etc., is a wildcard. So if you want to use express to evaluate a multiplication of, or the multiplication of two arguments, just escape the asterisk using a backslash. The backslash character is the official escape character within the bash environment and many other environments as well. So now it works perfectly. We can do division, for example. So let's say 100 divided by 100 should return 1. Any number divided by itself will return 1, etc., and so on. Express can also do other things. Let's say you need a counter within your script so that after a section of a loop runs, instead of using the let command. The let command is a command that allows you to perform simple addition, which we certainly show you. What if you just wanted to use express? Well, you can have a variable or set a variable. Let's say we set I. I is equivalent to 1. Now we can echo I, and you'll see that I is equivalent to 1. Let's increment it. Simply express, and what you want to do is set I to the new value. So I is equal to express. We use command substitution here, and it's I plus 1, and it doesn't change. Separate the arguments by spaces from the operator, and now I is equal to 1 plus 1, which is 2, and we don't need a $sign here. Now when we echo I, it's 2. So this is a simple way that towards the bottom of a loop, for, while, etc., you can stick an incrementer that increments by any value that you want, not necessarily 1, so you can step it to whatever level that you'd like. So express can perform simple, neat tricks for us. What about dealing with strings? Dealing with integers is typically quite straightforward. What about strings? Well, let's compare two strings. We'll express Linux CBT is equal to Linux CBT, and you'll notice something funny here. Unlike the bash environment, express returns a boolean true, which is 1. 1 is true in boolean. Let's change it to show you that it would return a different value. We'll make the left Linux CB lowercase t. It returns 0, which is false in boolean. So express adheres to boolean logic, true or false, versus Unix logic, Unix shell logic, which says 0 is true, 1 is false, and anything else is false. So we can compare strings. These are just two basic strings, and these don't compare because the cases are different. What about the length? Sometimes you want to know the length of a string. Well, express, let's say for example, here's our string, Linux CBT, and it returns the length if we specify the length of the string. So this time we want the length. Instead of just echoing it, express by itself will echo it. And the string Linux CBT has 8 characters. So, for example, you may have some logic which says if the string has more than X characters, perform some sort of function, or if it has less than, or whatever, if it's equal to, those are the strings that you're interested in. So we can ascertain the length of a string, which is quite easy. We can select a substring. So, for example, let's say we wanted not just the length from Linux CBT, but a substring. Well, just follow the help, the man pages, which instructs that you specify a substring. Here's a string, Linux CBT. We'll begin with the first character. Now, the first character is an index at array element 0. If you have any programming background at all, you may be accustomed to all things computers and array-oriented and list-oriented being indexed at 0. With Express, when evaluating a substring, or evaluating a string in general, the index is 1. So we'll begin at index 1, and we want the first 3 characters. This will return lin. If we wanted 4 characters, we get linu, 5 characters, etc. Now we've been operating on static strings. This also works on variables. So we can set a string, let's say var1 is equal to Linux CBT, and then operate on var1. So if we wanted to get the substring from var1, just simply specify var1, and it works just the same way. We can also get the length just the same way based on the variable, since ideally in your program you're going to use variables. So we've talked about the time command, which allows you to time how long it takes to run a program, and there are all sorts of programs on your system. ls is quite common. How long did it take to run? We've also talked about the date command. The date command accepts all sorts of formatting options, some of which you'll see us use, and the date command is very important for all sorts of applications. For example, just think about, let's say you have a script which outputs to a log file, and it outputs for good or bad, standard error or just standard out. It just sends to a log file items or things that you deem important. Well, you may want to name your log file or give your log file a prefix or a suffix of the date and timestamp or date stamp or any combination of those variables. Well, by using the date command, we can set a variable to whatever we want based on the formatting here and end up with a log file. Let's just show you a quick example of that without even writing a script. If we were to do, for example, date plus %f, it echoes 2004-10-20. But what if we wanted this particular string derived from the date command embedded within our file name? That's quite simple. We'd simply create this new file name. Now we can use touch, if you recall, to create a new file name. And we'll prefix or suffix the file with what we've just instructed or what we've just executed. Now let's say we want it to be the prefix. You simply do within backticks. Backticks allows us to perform command substitution, which we certainly talk about, which is a neat way using most scripting languages such as Perl, Python, PHP, etc., as well as Bash, to have the shell run commands for us and make use of the command's output. So we'll touch date plus %f. This will capture the output of the date command exactly between the backticks so that we can make use of it. And then we'll append a suffix of perhaps log. And this will create a file, 2004-10-20.log. Now, if we lsltr, you'll see that there's a new file that has been created called 2004-10-20.log. So in your script, you may want to send output using redirection, for example, perhaps using the cat command and some string, or maybe some file, or maybe you want to just echo. Perhaps this is a test, so let's clear screen. We'll clear screen, and maybe in your log file you may want to say something like echo program succeeded to your log file, and we'll use redirection, append redirection, and we'll simply use command substitution, which will give us date plus %f n backticks dot log. Now we can cat 2004-10-20.log, and it contains program succeeded. Now let's dump that file because we don't actually need it, but we just wanted to emphasize how easy it is to make use of the date command. And again, the date command has all sorts of options. We just showed you using %s, for example. %s is important because within Unix and Linux, the epoch is the point of reference with respect to time. So regardless of scripting language or environment that you use within Linux or Unix, there is always a reference made to the second since the Unix epoch, which is January 1st, 1970. And as a result, you need to know how to make use of it. So by simply saying %s with the date command, it tells you the number of seconds, but that's in relation to now. What about all of the other date timestamps that we see throughout our system, such as those that are a part of files? Well, we can express those date timestamps based on the Gregorian calendar using the Unix epoch standard quite easily. We can perform comparisons based on the Unix date representation format, which is much easier to calculate, although many programs provide, or many environments, scripting environments provide functions that can perform date calculations, although some under the hood really translate the date time representation to the Unix epoch time, number of seconds since 1970. And there are other formats here. This one is interesting, the %n. This is a cool way to generate a random string. So let's say, for example, date plus %n. It gives you a random string. It's really the number of nanoseconds, so it's as close to random as the date command will provide. If you notice, every time we run it, even if we run it fast, the strings are different. If you need to, for example, return some sort of cryptic or one-time value for use, or assign a password, or make this be a part of a password, or store it in a database, or store it in a file, just use date plus %n. It provides a nice, easy way of generating a wild string. It's a pretty long string. In fact, this one contains 9 characters, so you can have fun using this. So date plus %n, and there are other options. Anything related to the typical Gregorian calendar you can export: month, day, hour, minute, etc. You can even read from a file a series of dates and represent them in a different format using the F option. So the date command is quite important. Research it if you're not too comfortable with it, because within the bash shell environment there's no other way to get at the date. You need to use the date command explicitly and turn on or off the different formatting options that you're interested in. We've talked about the express command. If you need to evaluate an expression, something typically provided by other scripting environments, a facility typically provided by other scripting environments, use express. It should be able to express some common evaluations for you, such as the comparison of integers, strings, basic string comparison, such as whether or not the strings are equal, and perhaps the length of the string. You can ascertain the length. You can also extract substrings. You can perform matches. Some of the basic things that you're likely to do within your shell script when dealing with strings. So we're going to look at some of the other basic commands that you'll see us using. And even if you don't see us using it, you'll see them used in other shell scripts, or may want to use them in your scripts to tailor your scripts.